The history of computing began with a computer that was no more or less than the size of a building and had the power of a handheld calculator. Since then, the goal has always been to make it smaller, faster, smarter, all while using less energy, leading to a series of revolutions: personal computers, laptops, smartphones to the cloud, and the Internet of Things. In recent years, the IoT has grown at a rapid pace. In 2020, experts estimate the number of connected objects at 31 billion. To give you an idea, that's about 10 times more than the number of smartphones in circulation in 2018, or 4 times the world's population. In order to improve the functioning of the IoT, it is essential to develop new, eco-friendly technologies that allow to reduce energy consumption and thus increase autonomy, which remains the Achilles heel of connected objects. Thus, new microprocessors, a better communication network, and low-power memory integrated into the device are under study. And it is this last theme that will interest us. Indeed, in order to build memory devices that are more efficient than the current generation, researchers from 5 European countries, including the largest European semiconductor company, have come together in a consortium called 3εFERRO, funded by the European Commission via an H2020 project. Their objective: replacing the flash technology of non-volatile memories. These technologies have insufficient endurance, with a maximum of 100,000 operations and slow writing speed. The 3εFERRO team therefore turned to a new technology: ferroelectric random access memory, or FRAM. We use an extremely thin layer of oxide called hafnia, or HFO2, which has a unique characteristic. It is a ferroelectric material, which means that it can reverse its polarity when an electrical voltage is applied to it. It is this polarity that carries the information. Its strong point is that the information is conserved even at 0 voltage, which makes the memory non-volatile. Furthermore, as a simple voltage is sufficient to switch the polarity, energy consumption is considerably reduced. Finally, this memory targets an endurance of 100 billion operations, 1 million times more than flash technology. The advantage of hafnia is that it is fully compatible with conventional, silicon-based industrial processes. It can be implemented on existing wafers with a limited number of steps. To facilitate its integration, the researchers at 3εFERRO have added zirconium oxide. This makes it possible to decrease the all-important crystallization temperature from 900 to 450 degrees, and thus avoid damaging all the existing circuits on the wafer. Beyond the creation of this original material, the teams at 3εFERRO are working on easy-to-implement circuit and logic designs that will further reduce the power consumption of future wafers. Once tested to validate their reliability, these wafers will be at the origin of a new environmentally friendly technology, allowing everybody to enter the digital era.